I'm Dane, and this is Dane Explains. It's that time of year again, when temperatures in the northern hemisphere drop. And for most, it gets below freezing. When most substances get cold and freeze, the resulting solid is smaller than it was when it was liquid, due to being colder. However, you've probably noticed that when water freezes and becomes ice, that the ice usually gets a large bump on the top, or, if it's in a steel container, cracks it. This is because water expands its volume almost 9% instead of shrinking when it freezes. Why does it do that? And why would Earth probably be lifeless if it didn't? Let me explain why. In engineering, the fact that most materials expand when heated and contract when cooled is an effect that engineers both use to their advantage and try to fight if it's undesired. Many crisp-fit parts for machines need to be cooled to shrink them before they can be inserted, or they risk getting galled or warping. On the other hand, there are cases where engineers have to try to compensate for the expected contraction or expansion, like with the SR-71 Blackbird, a famous retired American spy plane. It flies so fast that its outer skin would expand. To compensate for this, the engineers had to leave seams and openings in the plane that resulted in leaking fuel constantly if it wasn't flying at a high speed. Most substances are like this. Even if it undergoes phase transition from liquid to solid, and vice versa, they continue to expand when heated and contract when cooled. This expansion and contraction is something that happens on a molecular level. As caused by the bonds between the atoms lengthening and contracting. As the solid is heated, it causes the molecules to shove and butt against each other more vigorously, stretching the bonds out. Eventually, the energy gets so high that the molecules are able to break their bonds and move around each other. This process is known as melting. Freezing is the opposite process. As the energy leaves, the atoms or molecules get closer together until they form permanent bonds. Why is water different? This has a lot to do with water's polar nature and the shape of the water molecule itself. Water molecules have a bent shape. This shape causes the atoms of the molecules to have an uneven distribution of electrons, where the oxygen atom pulls electrons away from the hydrogen atoms, making the hydrogen atoms positively charged and the oxygen atom negatively charged. So if you have many water molecules, the negatively charged oxygen atoms of one molecule are attracted to the positively charged hydrogens in the other water molecules. This is known as hydrogen bonding. In order to freeze when cooled, the water molecules have to orient towards each other in a certain way to create a crystal and become a solid. This creates gaps that would otherwise be filled by water molecules if they were still in a liquid state. So, as it freezes and becomes ice, it expands and also becomes less dense. This process actually creates a large energy barrier to complete or reverse. So to melt a block of ice and not even get it to raise any temperature at all, you would need to put as much energy into the block as it would take to raise the same amount of water's temperature by 176 degrees Fahrenheit, or 80 degrees Celsius. That means if you kept heating that water until boiling, which is 212 degrees Fahrenheit, 45% of the total energy put in to do that would be used just to melt the block of ice alone, and the rest of the 55% would be spent heating the water to boiling from 32 degrees Fahrenheit. This has many implications in engineering that are outside the scope of this video. So let me know if you'd like to see that, and I'll do a video on it. Because water expands as it turns into ice, its density also decreases. So a bucket of water holding 1 cubic foot of water would weigh 8% more than a bucket of ice that's also 1 cubic foot. Because of this, unlike most substances we know of, ice floats on water. The solid property of water is actually critical for life on Earth. As I've talked about on my channel before, there are several points on Earth's history called snowballearth, where the whole Earth was covered in ice. So, if ice was heavier than water, it would have sunk, revealing more liquid water, which would freeze, and so on, until the oceans froze completely, killing all, or at least stopping all life on Earth in its tracks. Instead, the ice acted as more of a protective patina, like a patina does on metal, acting as an insulating layer, protecting the water underneath from freezing, and giving life a place to hide while the surface was frozen. That's why the fact that water expands when it freezes is critical for Earth life. Thank you for watching. If you like this video and other topics ranging from theology to science, please press the like button, subscribe to my channel, and ding the bell to get notified when I post new videos. Also, please support me on Patreon to get extra content and special perks. Link in the description. The more people support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.